Hello, welcome to another PlayBASIC live video. I wanted to talk a bit more about optimization. And this time we'll talk about graphical optimizations we can make. One in particular is dirty rectangles. And then, if you missed the previous video about the talks about optimization, it's on the forum here somewhere, or on the YouTube channel, whatever you prefer, really. Actually, might be in that one there. Yeah, there it is. Basic optimization with overview of forms. Talks about a lot of things actually. At the end, we're talking about optimization primarily. In particular, we're talking about a particular thread on the forums. There's on the forums here, we've got the PlayBASIC area, and this is well, anyone can just access this stuff here. You don't have to be a member to read this stuff. Down to tutorials, and it's a tutorial called, there it is, a crash course in basic program optimization. It's a bit of a long one, so hopefully it's the kind of thing you'll come back to and pick at and sort of pick up some ideas from it. We've broken into redundant calculations, which is kind of what we talked about last time. This time we'll talk about some sort of ways to make drawing in your programs faster or better. We can think about ways of making our logic in our games faster as well. So redundant calculations are these kind of little niggly things like this, where we've got loops that have got full of array or type access within them. We can try to shortcut this stuff by pulling the data out of the structure into a variable, using the variable, and then when we're done, throwing it away or writing it back to the structure much quicker. Things about times when you shouldn't call functions inside loops, for example. You can add lots of overhead to your programs without you even noticing sometimes. And this stuff here was all kind of covered, and there's a bit of stuff, a bit of other chit chat going on through it. I can't remember exactly what we talked about, to be honest. It was a while ago. So this stuff here is the section here I think we glossed over it a bit, but so I wanted to sort of go back and do another quick. I apologise for doing this. This stuff I do it fast, but it's the way it is, unfortunately. So we've got a section here about ideas for when we can, do we really need to clear the screen backdrop all the time? Got a bit of an example there. You can try that yourself. Yeah, you can kind of imagine most simple game loops a bit like this, really. You've got this kind of CLS, do CLS, and then some drawing code, and some game logic code, a bit of a sync and a loop back. If you have a backdrop in your game, like I've got here, if you're clearing the screen first, you're writing to every pixel on the screen. And if you're drawing an image that's the same size as the screen to the screen, confusing I know, provided that image is not transparent, has no see-through parts of it, it's completely opaque, the CLS becomes redundant. So we could halve the amount of drawing work that this bit of code here is doing just by doing that. Now, this is not, you can't just add this to any piece of code. You've got to make sure that if you're rendering the backdrop as an image or partially as an image or whatever, then you might use a box to clear the other part of the screen, something like that. My point is that you don't really want to be drawing to pixels multiple times. And an easy way to stop doing that is just to check whether you actually need to clear the backdrop or not. Often you don't. But that's kind of a very per game situation. here we're talking about transparency in images. You might not be aware, but when you have a pixel, each pixel in an image costs something to draw, whether it's transparent or solid. And the cost is actually can be quite different based on whether it's a video image. So if you're drawing a video image to a video into the screen, which is video memory, or you're drawing an effects image or those kind of things. I made a video about that recently. It's over here at the moment. It's well worth having a bit of a look through if you're not up to date with that stuff. I suspect most people are probably either a bit rusty or not that up to date with it. Got some links down here to some more reading you can do. This stuff here is in the help files already, but maybe it's easier for you to read on the forum, I don't know. Back to our point. So when we're drawing these pixels, if you have an image that say, I think the test is running 100 by 100 pixels, and we're drawing something to it, then even if that image is blank, it costs time to draw a blank image. Every pixel costs you performance. So if you're drawing an image that has, let's say, a character with a big transparent border around it, then that's actually costing you performance. You're not doing yourself any favors by storing it like that. So an easy way to win back some performance is trimming off the edges around sprites. There's some material down here that talks about that. Some ideas about how you might tackle it. So we've got fixed size versus trimmed animations, and so it's no surprise that the trimmed animation runs faster. And here we're really talking about some pretty low end systems. So the gain is you can achieve a really good gain on pretty much any system. So don't assume that this doesn't apply to you. So another thing we can do with graphics is we can change our display depth. These days people like to play in a window, I would say. So it's probably not that applicable, but you can use full screen exclusive modes. And if the system that you're playing on has a 16-bit mode, and your artwork doesn't really need lots of gradients in particular, then you might just want to run it in 16-bit. Save yourself a lot of, the difference between running a game in 16-bit and 32-bit is that you're halving the amount of work per pixel straight out. It's a big thing. Another little tip here is about drawing everything real time. Sometimes we just don't need to refresh and redraw everything all the time. Often you could just schedule things to be only updated on every second frame or every 10th frame or whatever it might happen to be. The player doesn't even notice. Hopefully they're more fixated on what the game is about than oh well, this object here is not being refreshed all the time. One trick is that slow moving objects in games are often easy ways to cheat. So you probably think of some way where you can have that character be updated or being drawn, but not really being drawn all the time, if you know what I mean. Now, this is the section I wanted to get to. This is dirty rectangles. It's a concept that operating systems use all the time for redrawing the screen. They try not to draw the whole screen all the time, and we shouldn't be any different. Whether you use high-end GPU to render the frame, or whether you use the oldest, Pentium, low-end Pentium that's available on the market, where you definitely shouldn't just try and draw everything every frame. Be more selective about how the frame is composited. We've got selective tile mapping. The next part's a bit more about some sort of algorithms you can use to help go. But I wanted to have a look at the sturdy rectangles. We've got a couple of examples here in the forums. So I'll chase this one here up. I think that's the one I was looking at before. Now I've already actually loaded this stuff up, and we'll go through it in the IDE. What it does is it just creates a random backdrop and then has some just AFX images running around. It gives you an idea of how much of the frame is being redrawn each frame. Let's get rid of that junk. I apologise for sort of trying to get through this quickly, but time is a real precious thing at the moment. Now I think it's that one there. There's a couple of these examples and they actually work. They do the same thing, but they use two different methods. So we'll see which one this one is. Okay, that seems to be running alright. Capture's doing a bit of a number on it. So if I hit the spacebar, I can add some more. Up in the top corner here, it's giving us an idea of how much of the frame needs to be redrawn each frame. So I've got these moving characters, but only 30% of the whole screen is being drawn to and affected. Capture's killing our frame rate, but that's alright, doesn't matter. Now the point we want to get to with this particular example is that we can do, if you've got a very traditional 2D game, for example, you could just do selective refreshing of the backdrop. I'll stop that from running now. And in this particular example, it uses a map. It converts the backdrop into a tile map. Each tile is 32 by 32. I think it just makes a random junk map. Yeah, it does. So we're just making that terrible backdrop before, rather than loading some image in to make the example smaller. So we're making the backdrop picture. We're making our blobs that were our moving sprites, defining our structure for our moving sprites, our characters, creating the area which the screen takes up, the clipping area really. Then we get into the series stuff and we make a map. We get our backdrops width and height. We convert. We work out how many tiles wide and high this thing needs to be. We round them out just to make sure that our backdrop's going to be bigger than our screen, or at least the same size. Work out how many blocks is going to be. Create the map tiles, and we allocate a level within our map. We run through and grab each section of that backdrop image as a tile for our backdrop. Okay, so we're going to end up with a couple of different levels, or you might think of them as layers actually. In the map, we've got one version that's the original version, and then we've got one version that we're going to draw to and update each frame. And at the end of the frame, we copy one over the other to reset it. Okay, so let's get down to the main loop here. We've got a bit of code here to check whether we should add a character to the scene, just so I can hit space and add more to it. We're redirecting all our rendering out to an effects screen, locking the buffer, drawing our map to that buffer. Then we're clearing the level. So we're saying we're clearing the level to the transparent tile. So if I was to draw the map now, it wouldn't draw anything. We run through, we update our characters. For each character, we work out the area around the sprite in relation relative to the map. Once we know that point, we copy those tiles from our original level to our refresh level. Because this is the area that needs to be redrawn to remove the sprite from the last frame. God, I hope that makes some sense. So what we're doing is if two sprites share the same area, we're not actually preserving that backdrop. We're just using copy level to set these set this part of the map. Does that make any sense? Geez, I hope so. So if two sprites are sharing the same area, we're drawing the two sprites, but we're not drawing the backdrop multiple times or preserving the backdrop multiple times, which is, if you're familiar with how software sprites generally work, what you normally do is before you draw something, you actually preserve the backdrop, and then you draw your sprite over the backdrop. So at the end of the frame, you reset the backdrop by running back through and copying those things back in backwards, copying them backwards. It's a very inefficient method, and this way is a lot more efficient because you're not actually doing, you don't have to copy anything out. You can just tag which parts of the map need to be refreshed. In this case, the map represents the backdrop image, and then we just keep doing it. We just keep refreshing it. Here we're working out, running through the map and going, well, how much of this map is actually being drawn each frame? That's the bit of code that makes the translucent blob. Let's look at it again. You'll notice that my cursor is actually showing one map tile. So the sprites are probably about, I don't know, maybe 4 or 5 tiles for each one. Probably 3 tiles by probably 2 tiles there. And depending on their position relative to the map, they're refreshing different numbers of tiles. The key point is that we're never redrawing the whole screen. So for most classic 2D games, it's quite an efficient way of doing them, and this works on really old hardware. I'm talking about 10 years plus. It's not too happy with me trying to capture this and run it on this system. This is a very slow Celeron all-in-one system. It doesn't really have anything much in it, but it does for making these videos. So I just go over that over the inner loop again. So our point, the whole idea of this is we make our backdrop image. Of course, in a real game, you would have your backdrop preloaded as a map, but here we're actually constructing the whole thing just in code, just so we don't have to give you supply artwork. Makes the package smaller. So what we're doing here is we're making a map representation of that backdrop image, which is what this code here does. Works out how many tiles wide the thing is going to need to be, how many tiles high it's going to need to be, working out the number of blocks we'll need, creates the blocks space for the blocks inside the map. We create a level inside this map, which is just the tile map, really. You might know that terminology better. Then we run through our backdrop image, grab blocks from it and put them in our map, just sequentially, one after the other. We also write these indexes into our level, just until we've got through the whole backdrop. We make a second level, because we're going to use 2 levels. One's going to be refreshing the other. So one we don't touch, and one we're refreshing each level. That keeps the difference between the original map and the current map at the end of the frame. So after all the sprites have been drawn, the map will have certain parts of it that need to be refreshed to restore the frame to how it was originally. Yes, I hope that makes sense. A bit of logic to do sprite additions. So the only real difference to our regular sort of draw loop is just that we when we draw our characters, we just have a bit of code to work out, well, what space on screen is this sprite covering up? And we're using that area, or working out what tiles on the screen, tiles within the map I should say, that's going to be. We're copying them from the original map to our original level within the map, and our refresh level within the map. Hard to wrap your head around, isn't it? And once we've gone through all the sprites and done that, we can just display the screen, drawing the mouse pointer at some point, going back and doing that. So next frame, come through, redirect our drawing back to our screen, and here we're redrawing the parts of the screen that changed last refresh. So this clears off where the sprites were last frame, resets the backdrop to how it was originally. We clear this refresh level, so all the tiles there are now transparent. So if we were to draw this map again, nothing would get drawn. But we run through our character logic again and do it. Okay, so that's dirty rectangles. There's a lot of different ways you can use that logic. I think in one of the other games there I used a similar idea to do when I had GUI elements on screen. I was drawing the backdrop as a map, and then when the GUI was on screen it was occluding the backdrop, so I was just clearing off the refresh parts of the backdrop map. And you'd be surprised how much time that saves. We do actually have in PlayBASIC, we do have in the map section down here, if you haven't actually cracked it open and had a look, I've noticed a lot of people have just kind of ignored maps altogether. We've got maps here there's a bit of creation, maps, animations, all that sort of stuff. But down the bottom we've got some occlusion functions. These actually let you do kind of simple. You can if you have two map layers that overlap each other, you can pre-compute where those overlaps are. You can remove a circle from the map or do this kind of stuff. We'll see if that works. I'm using one of the betas at the moment, so I wouldn't be surprised if it doesn't work. Okay, so you can see what it's doing there. It's culling out those tiles, so I can have a circular sprite in front and then clear that away. Oh well, that'll have to do. So thanks for watching, and I'll catch you next time. Bye.